Thank you very much for the introduction. Looking forward to be here today and speak about my work on simulation to real-world transfer. It is a pretty ambitious title, and I hope that I'll be able to keep up with it. So let's start with a question which has inspired my research for long and has actually inspired the philosophers for millennia, which is, what is perception? We can see already the beginning of a theory of perception in Aristotle's book, De Anima, where the main hypothesis put forward was that perception is a form of reception. You receive the objects, their 3D shapes, without their matter. This idea of perception put forward by Aristotle has had an enormous impact on the way that we do perception still today, for the next 2 millennia, I would say. In fact, if you go look the book Vision by David Marr, which was written in the late 21st century. Well, what you'll see is that also here we see a very similar theory of perception, just from the engineering perspective. The idea of Marr was to build engineering systems that mimic the way that the human perceive. And this is the theory that he came up with, an information processing theory of vision, where vision is seen essentially as the opposite of computer graphics. What you try to do with vision is you start from some images, extract some edge information, then go from edges to 2.5D, and then from there to a 3D model in a sequential procedure. As you can see, this looks like a very software engineering perspective of perception. Modularity is a well-understood concept and something that engineers really like. You can put one person working on this, another person working on that, and by the end of the day, if everything works, they can merge their work. Okay, so this was the idea of perception, reconstructing accurate 3D model of the world, reconstructing objects in general without their matter. However, if you go and look at the data we've done by, well, not only recent studies, studies from quite some time already, they show you that this theory of perception does not fit human data. Humans do not recover the radical